be drawn for continuous grouped data. So what do we do when the data is discontinuous, as in this frequency distribution table? Here, the intervals are discontinuous. So first, we need to convert the discontinuous intervals into continuous intervals. How is this done? For converting them, we need something called the adjustment factor. Adjustment factor is equal to half whole into difference between the upper limit and the lower limit of the next class. Here we have adjustment factor is equals to half 21 minus 20, which is equal to 0.5. To convert the given class intervals into continuous intervals, we need to subtract the adjustment factor from the lower limits of all the intervals and add the adjustment factor to the upper limits of all the intervals. For the first interval 11 to 20, the lower limit 11 becomes 11 minus 0.5, that is 10.5, while the upper limit 20 becomes 20 plus 0.5, which is equal to 20.5. Thus, the first interval becomes 10.5 to 20.5. For the second interval 21 to 30, the lower limit 21 becomes 21 minus 0.5, which is equal to 20.5, while the upper limit 30 becomes 30 plus 0.5, which is equal to 30.5. Thus, the second interval becomes 20.5 to 30.5. Similarly, the third interval becomes 30.5 to 40.5, while the fourth interval becomes 40.5 to 50.5, and the fifth interval becomes 50.5 to 60.5. Once the intervals become continuous, we proceed to draw the histogram as our earlier question. We choose suitable scales. Since the size of the class is 20.5 to 10.5, that is 10, therefore we choose scale on x-axis as 1 centimeter is equal to 10 units. On the y-axis, we choose scale as 1 centimeter is equal to 2 units. Label x-axis as class intervals and y-axis as frequency. Before we proceed to draw the histogram, we notice that our classes do not start at 0 and that the first class starts at 10.5. Since 10.5 is not equal to 10 units, therefore, this means that the first 1 centimeter on the x-axis represents 10.5 units and not 10, as we had chosen as scale. We know that in a graph, the scale must be held for all units. To avoid this problem, we use something called a kink. This kink can represent any number of units. It is used to ignore the units before the first class interval. Now we proceed as usual. We mark 10.5, 20.5, 30.5, 40.5, 50.5 and 60.5 at equal distances on the x-axis and mark 2, 4, 6, 8 and 10 on the y-axis. First, taking the first interval 10.5 to 20.5 as base, we draw the rectangle with 10.5 to 20.5 as the base and 5 as the height. Similarly, we take the second interval and draw the rectangle with 20.5 to 30.5 as the base and 8 as the height. We proceed to draw other rectangles in the same way. The resultant graph we get is the histogram. Let us now learn something called cumulative frequency and the curve obtained from it. The cumulative frequency of a class interval is the sum of the frequencies of all the classes up to that class interval. Let us illustrate this. Look at this frequency distribution table. Let us make the cumulative frequency table for this frequency distribution table. For the first interval 20 to 25, the cumulative frequency would be the sum of the frequencies till this interval. As there are no intervals before this interval, therefore, the cumulative frequency and the frequency of the first interval will always be the same. Thus, cumulative frequency of the first interval remains 3. For the second interval 25 to 30, the cumulative frequency would be the sum of the frequencies of the first and second intervals. Therefore, cumulative frequency of the second interval is equal to 3 plus 6, which is equals to 9. For the third interval 30 to 35, the cumulative frequency would be the sum of the frequencies of the first, second and third intervals. Therefore, cumulative frequency of the third interval is equals to 3 plus 6 plus 10, which is equals to 19. For the fourth interval 35 to 40, the cumulative frequency would be the sum of the frequencies of the first, second, third and fourth intervals. Therefore, cumulative frequency of the fourth interval is equals to 3 plus 6 plus 10 plus 8 is equals to 27. For the fifth interval 40 to 45, the cumulative frequency would be the sum of the frequencies of the first, second, third, fourth and fifth intervals. Therefore, cumulative frequency of the fifth interval is equals to 3 plus 6 plus 10 plus 8 plus 4, which equals to 31. The new frequencies so obtained, that is 3, 9, 19, 27 and 31 are called the cumulative frequencies. And the distribution table with the class intervals along with the respective cumulative frequencies is called the cumulative frequency distribution table. With the cumulative frequency table, we plot the points taking the upper limits of the class intervals as x coordinates and the corresponding cumulative frequencies as y coordinates. Let us plot the points for the cumulative frequency distribution table we just formed. Here, the two axes, we label the x-axis as class intervals and the y-axis as cumulative frequency. We take the scales as 1 centimeter is equal to 5 units on the x-axis and 1 centimeter is equal to 4 units on the x-axis. Since the class interval start at 20 and the class size is 5, use a kink and proceed to mark the x-axis as 20, 25, 30, 35, 40 and 45 and mark the point 4, 8, 12, 16, 20, 24, 28 and 32 on the y-axis. For marking the points, we take the upper limit of the class interval as the x coordinate and its corresponding cumulative frequency as the y coordinate. However, remember, the first point is always on the x-axis. It represents the lower point of the first class with cumulative frequency as 0. Thus, our first point would be 20, 0 as 20 is the upper limit of the first class 20 to 25. Next, the upper limit of the first interval is 25 and its corresponding cumulative frequency is 3. So, our point is 25, 3. Our next point is 39. We go on to plot the points 35, 19, 40, 27 and 45, 31. We then join these points by a free hand to get a curve. The curve we obtain is called a cumulative frequency curve or an ogive. With this, we come to the end of this chapter. You should be familiar with the following keyword and phrases: frequency, class intervals, continuous data, discontinuous data, frequency table, histogram, cumulative frequency curves or ogives. In case you still have doubts with these topics, please feel free to ask me. Till the next time we meet, goodbye.